Alright, good afternoon everyone. Hope you're all doing well. So I'd just like to introduce myself. So my name's Joe, I work for a company called Hudl. We're a sports video analysis tool. Started up in the US and just coming over to the UK now. So just about to go all through that. So overview of what I'm about to talk about. I explain what Hudl actually is, and then walk through to give you an idea of how we create that data, what we actually do with that data, and go into a very specific example of how we're using deep learning to automate certain parts of the video, add more value to the app. I'll tell you more about the problems and challenges that the data team's having right now, and perhaps you can empathise with some of those as well. And then at the end we'll just finish up with some questions, and I'll tell you about some of the data hires that we're looking to make. So just a very quick introduction about who I am and why I'm actually speaking to you. So I'm actually a tech recruiter for Hudl, based full-time from our office based in Islington. So I bet you're thinking, why is a tech recruiter speaking to you about data science? Well, there's two reasons. Firstly, the data science team is based in the US. So they're based out of our headquarters in Lincoln, another office in Omaha, and remotely throughout Texas and California as well. So I guess there's a little bit of bragging about me, but also the second reason is that up until I started at Hudl, which is at the beginning of May, I was a data specialist recruiter for almost 2 years. So just managed to get myself featured on the Analytica report, the top 50 individuals in big data, right down here at number 12. Very happy about that. So I thought I'd just show you all. Also had a data science blog called Joe Blogs. Very witty title, I know. I've featured in Data IQ writing about how to make data science hires, etc. And that's my LinkedIn profile picture, just in case I've requested to connect with you. Also, I tweet about data, so this is the best tweet I've ever done, and it happens to be to do with data. I'll leave you to read that and then shuffle. Yeah, pretty fun. Yeah. If you did want to follow me on Twitter, it's at Joe Finds Talent. So, what is Hudl? Well, firstly, I'll explain what Hudl is not, and that is the tablet made by Tesco. So, I was actually at a hackathon on Monday, where there was loads of Tesco signs everywhere because they happened to be in the same office building as some of the Hudl for Tesco employees, so that was very confusing. So, no, we are not there. So we're Hudl.com, they're Hudl.co.uk. Hopefully one day we'll get that back. And what I'm going to do now is show a 59-second video of who we are, just to get a good start, and so I can stop speaking for about a minute.
Film. And once the video is uploaded, add notes and illustrations and share those with the rest of the team. If you're connected to Wi-Fi, your video will upload on its own. Check the team stats live at the event, because Hudl will automatically sync your video and your stats, so you can see every turnover, rebound, and other key moments right after the event. Using Hudl's exchange feature, you can send full games to other teams and receive their film to scout opponents. Athletes can create highlights for friends and family. You can send full game footage and academic credentials to verified university recruiters. You can access your video anywhere, anytime. Hudl breaks your film down in minutes, giving you time to do what you want.
So yeah, that was pretty quick. But I'll explain where we came from and what the initial problem we were trying to solve was, again, just to get a better idea of what we actually do, and again, where the data comes from. So yeah, cast your mind back to 2006. Our three co-founders all did an MBA joint engineering degree together at the University of Nebraska, which is that state there. Usually most people have no idea which one that one is, but it's almost the size of the UK, funny enough. So at the University of Nebraska, they doing their MBA engineering course, they had to do a project with a business. So they decided to do that with their local university team called the Huskers. And what they realised with working with coaches, like immediately the problem was that coaches were burning like 175 DVDs a week. They're printing out phone book sized playbooks that included all the stats, all the different variations of the game. If I haven't mentioned, it's American football, so it's incredibly complicated. So many different scenarios for each one. So I thought I'd just bring up this picture because we all know how annoying paper is, especially on Thursday. So very easy solution. It was quite phenomenal, in fact. We're going to use the internet to store all of that video, that's practice video and game video, and all of the stats, all the playbooks, etc. Store them somewhere securely so that coaches can log on to the web and upload a video. The athletes can log on and see all their highlights, all the practice game footage everywhere. If they're lucky enough to own a computer from home, then they can watch it at home as well. So just fast forwarding to 2015, how has that evolved and how has that changed? Well, we now have 92% of that market share in the US. That is 92% of high school and university American football teams in the US use Hudl as coaching software to make themselves better, and that's just growing and growing every day. We now have 3.5 million users worldwide, and that's 35,000 plus teams. So 2006 one team, coming up to now 35,000 plus teams, and that includes a whole host of now professional teams. For example, we work with every single team in the English Premier League. Also work with FC Barcelona and Bayern Munich. We work with 29 out of the 30 NBA teams in the US. If you're wondering who that one team is the Dallas Mavericks. So our business development team are hot on them at the moment. And we're also working with about 18 out of the 20 rugby teams in this year's World Cup, and majority NFL, and I could go on, but I'm not going. We are also proudly, we have the world's largest labelled database in sports in the world, as it says in the world, like that. What this actually means is that labelled means is tagged. If you get, say, 90-minute video of a football game, so player A scores in which minute, which second, player B does a throw in when, like the whole thing is tagged, so you can actually just see the whole game in data as you're going along. This means that it allows for a very structured database, which is amazing for our data science team. And also it includes all the metadata. So you've got all the metadata from player A, you know, all their stats all throughout the season, their height, weight, university they went to, etc. We also use Amazon Web Services. We've been using that for about the last 7 years. In fact, you store so much data on Amazon Web Services that we have our own personal account management team, which is great because we just call them on their mobiles all the time. And I thought we did include a little deal bit there just to get a chuckle. We have and are building a social network as well. So think about these athletes, they now have profiles with all their stats and all the video on there. They share videos, it gets liked, it gets trended by other athletes, and it goes from there. They can also follow other athletes, whether this is at high school or university. That's obviously the biggest market for that, but also can do it on the professional side as well. And these aren't open to the public. You have to be a Hudl user, which means your club has to be paying. So it's great just learn from each other, message each other, etc. And that also plays into our Recruit app or side of the application. So Hudl Recruit is for sports recruiters and talent scouts, saving them actually having to go down to the pitch and watching games. They can just look at these players' profiles, see all their stats, see all their video, go from there. That's Jerry Maguire, who's a sports agent, not a sports scout. Something really exciting which I'm going to get onto in a moment is computer vision. We have a team of 6 full-time computer vision engineers in our research and development department, essentially looking at automatically analysing video, which is just amazing, and I'll get into that shortly. And then just a bit of an update on what we're doing. Last 12 months we acquired these 3 companies. Ubersense in Boston, Replay Analysis in London, and we announced last month that we acquired Sports Tech headquartered in Australia. We also raised 72.5 million in funding in April, one of those being Axel, who really founded Facebook. Funded. Right, so what are we actually doing with this data? Well, we're in a bit of a gift and a curse moment at present, in that we're listening to the data. The co-founders said, right, we're going to have a data science team. We don't actually have the questions, so find the answers first and we'll come to questions later. So we have, I believe, 8 full-time data scientists and 6 interns working on this, just sifting through this massive database, trying to add value to the product, trying to add value internally. Like yourself said earlier, you're either going to save money or make money with the data. So just going to go through some proof of concepts and current work that we're doing. So one idea that we're working on at the moment is automating possession stats. In fact, a lot of the stuff we're working on is automation, just to make coaches' lives easier when uploading video, and just making the whole process of using Hudl a lot quicker. So automated possession stats, very simple. I say very simple, but we can also use computer vision to track player numbers, and we can see how much time they're on the ball using computer vision. The whole point of that is that we can get those stats not just from the game, but also from practice, help coaches actually plan who they're going to play, etc. Statistical outcomes of set pieces is very much being trialled in American football, but you can essentially have this in any other game. What you're going to do, what strategy you're going to use at a specific point in time. Like with football, how are you going to go about this free kick or corner, or coming back in half time? What sort are you going to be offensive, neutral, defensive? What sort substitutes should you make and when? And we'll give you a statistical probability of that. That's currently underway at the moment. Computer vision. So some great computer vision stuff that we're doing right now that is actually being used is working on our individual performance side of Hudl. So great example is with golf. So you can you want to be able to set up a camera and just record, say, 20 golf swings in a row. So if you just did that with any normal camera, you'd have to keep fast forwarding, skipping to your next swing, next swing, next swing. Or if you could simply just set up a camera, do your golf swing, it captures that piece of video, put it around, get your next golf ball, put it back on, and then it automatically detects that you're back in the golfing stance. And then do the swing, and then it will take that clip 2, and you can just keep going. So at the end, you've just got 20 clips of purely your swing. Also, what we're working on is automating like diagrams, adding to that. Also, you can currently compare your swing to some like Tiger Woods right there next to you as well. And data visualization is an obvious one. Every company's management information, but we're also working with our designers and front-end engineers to show you what data actually is presented to you, either in the app or on the web. Right, so this is where I'm about to go very in depth into deep learning and neural networks. But there's also 3 key projects we're working on at the moment in terms of recommendation engines. So the first 2 are quite simple, I'm sure you'd be aware of. The third one is a little more complex. So first one, who to follow. So on the social network site that I was talking about, very simple, like LinkedIn, Facebook, and Twitter all have these functions, recommended. Like for us, what other athletes should you follow? Second one's going to be what to watch next. So that's going to be like at the end of a YouTube clip, it kind of gives you an idea of what to watch next. And all of these as well are trying to keep you on the in the Hudl app, trying to make you use it more, play around, add more data to our database essentially. And the last one, which is I believe is going to be the most interesting part of my talk, is going to be where are the highlights in this game. So the whole concept around this is, imagine you upload your 90 minutes of football, and then automatically, seconds later, we pull out and say, we think these are the 3 top highlights from the game. And if, accurately pull out, okay, it's a goal from a free kick and an incredible save. Just automatically right there. You don't have to go through all the footage and pick out what you want. So how is this actually going to happen? Now, I spoke to the data science team and went through this in depth, but funny enough, they didn't really trust me too much to regurgitate what they said from memory. So quite nicely, William Spearman, who's on our data science team, before he worked here, he was working on the CERN project in Switzerland. It was actually documented as one of the guys who found the Higgs boson. So yeah, needless to say, he's quite a clever guy, good one for a pub quiz. So I'm just going to run through this. Just let me know if you're getting bored. Right, so at Hudl we'd love to be able to watch every video uploaded to our servers and highlight the most impressive plays. Unfortunately, time constraints make this an impossible dream. So there is, however, a group of people who have watched every game, and that's the fans. And rather than polling these fans to find the best plays from every game, we decided to use their response to highlight worthy plays. So more specifically, we will train classifiers that can recognise the difference between highlight-worthy and non-highlight-worthy clips. So highlight-worthy we're going to call signals, and non-highlight-worthy we're going to call background. The input to the classifiers will be the audio and video data, and the output will be a score that represents the probability that the clip is highlight-worthy. So, training example. So to select a sample of events to train a classifier on, we created a sample of 4,153 clips, each 10 seconds long, from basketball games. So apologies for that, from football games. No more than 2 clips come from the same basketball game, and most are from different games played by different teams. So this is to prevent the classifier from overfitting for a specific audience or arena, and about half of these clips are during which a successful 3-point shot occurs. So the other half are a semi-random selection of footage from basketball games. So, how did we do this? So we used Amazon's Mechanical Turk, otherwise known as M-Turk, to separate the plays with the most cheering from those with no cheering or no successful shot. So each clip was sent to 2 or 3 separate Turkers, and to separate highlight-worthy clips from non-highlight-worthy clips, we gave 2 or 3 Turkers the following instructions. So can everyone read that? Yep. So the distribution of average scores for the 4,153 clips is shown here. And clips that were unanimously scored as 3 were selected as our cheering signal, while clips that were unanimously scored as 0 are considered to be background. So this choice was made to provide maximum separation between signal and background. And moving forward, using a multi-class classifier that incorporates clips with a 1 or a 2 could improve the performance of the classifier when it is used on entire games. For the time being, however, we use a sample of 887 signal clips and 1,320 background clips. Is everyone following? Great. So I have no idea what. So pre-processing audio. So before sending our audio data to a deep learning algorithm, we wanted to process it to make more intelligible than a series of raw audio amplitudes. So we decided to convert our audio into an audio image, see on the right. That would reduce the data present in a 44,100 Hz wave file without losing the features that make it possible to distinguish cheering. So to create an audio image, we went through the following steps. Number 1, convert the stereo audio to mono by dropping one of the 2 audio channels. Number 2, use a fast Fourier transform to convert the audio from the time domain to the frequency domain. Number 3, use 6-octave bands to slice the data into different frequency bins. Number 4, convert each frequency bin back to the time domain. And number 5, create a 2D map using the frequency bins as the y-axis, the time as the x-axis, and the amplitude as the z-axis. So as you see over there, the whiter or the brighter the noise, you can see by that. So right in the middle here, we assume something awesome is going to happen. So video classifiers. Although audio cheering seems like an obvious way to identify highlights, it is possible that the video could also be used to separate highlights. We decided to train 3 visual classifiers using raw frames from the video. The first classifier is trained on video frames taken from 2-second mark of each 10-second clip. So the second is trained on frames taken from the 5-second mark of each clip, and the third is trained on frames taken from the 8-second mark of each clip. And so shown here are frames for an example clip at 2, 5 and 8 seconds. So moving on to the deep learning of this framework. Because our 2D audio maps can be visualized as images, we decided to use MetaMind. Is there anyone aware of MetaMind? Yes, one person at the back there. As our deep learning agent. So MetaMind provides easy to use Python API that lets the user train accurate image classifiers. So each classifier accepts as input an audio image and outputs a score that represents the probability that the prediction is correct, as well shown there. To train our classifier, we split our 887 signal clips and 1,320 background clips into train and test samples. So 85% of the clips are used to train the classifiers, while 15% of the clips are reserved to test the classifiers. In total, we trained 4 classifiers. So audio image, video frame 2 seconds, video frame 5 seconds, video frame 8 seconds. So to test how well each classifier fared, we consider the predictions of the classifiers on the reserved test set. Because the classifier was not trained on these clips, overfitting cannot be causing the observed performance on the test set. The predictions for signal and background for each of the 4 classifiers are shown in the plots here. The x-axis is the predicted probability of being signal, i.e. The output variable of the classifier, and the y-axis is the number of clips that were predicted to have that probability. So the red histogram indicates background clips and the blue histogram indicates signal clips. So, the receiver operating characteristic, otherwise known as the ROC curve, is a graphical way to illustrate the performance of a binary classifier when the discrimination threshold is changed. So in our case, the discrimination threshold is the value of the output of our classifier above which a clip is determined to be signal. So we can change this value to improve our true positive rate, so the number of signal we correctly classify as signal, or reduce our false positive rate, the number of background that we incorrectly classify as signal. For example, by setting our threshold to 1, we would classify no clips as signal and therefore have 0% false positive rate at the expense of a 0% true positive rate. Alternatively, we could set our threshold to 0 and classify all clips as signal, thereby giving us 100% true positive rate at the expense of 100% false positive rate. Is this all making sense? The ROC curve for each of the 4 classifiers is shown here. So a single number that represents the strength of a classifier is known as the ROC area under the curve, known as AUC. The integral represents how well a classifier is able to differentiate between signal and background along all working points, and the curves shown are the average of bootstrap samples, and the fuzzy band around the curve represents the possible ways in which the ROC curve could possibly fluctuate. So combining classifiers here. So because each of these classifiers provides different information, it's possible that their combination could perform better than any single classifier alone. So to combine classifiers, we must train a third classifier that takes as features the probabilities from the original classifiers and returns a single probability. So to visualize the performance of these combined classifiers, we make a 2D plot with each axis representing the input probability. So each test clip is plotted as a point in this 2D space and is coloured blue if signal or red if background. The prediction of the combined classifier is plotted in the background as a 2D colour map, and the colour represents the combined classifier's predicted probability of being signal or background. That's more example there. So, combined classifier performance. We create the ROC curves as before in order to evaluate the performance of these combined classifiers. So, as expected, the combined classifiers will include the audio classifier perform the best, and the improvement in ROC AUC from audio alone to audio plus video is 0.96 to 0.97. This is not a dramatic improvement, but it demonstrates there are gains to be had from adding visual information. So when two visual classifiers are added together, the ROC AUC increases from 0.79 to 0.83. So this increase indicates there is additional information to be gained from utilising different times in the video. So basically, that was all worthwhile. A final combination of all four classifiers was performed, but this ultimate combination was no better than the pairwise combination of audio and video. So this indicates that further improvements to our classification would need to come from tweaks to the pre-processing of the data of the classifiers themselves, rather than simply adding additional video classifiers to the mix. So we're getting on to the full game testing. So to evaluate our classifier in the wild, we will split 4 games into overlapping 10-second clips. Now, overlapping clips means that we make clips for 0 to 10 seconds, 5 to 15 seconds, 10 to 20 seconds, etc., all the way through the game. These clips are then passed through the audio classifier. Our goal in doing this is to answer the following 3 questions. So, what is the distribution of probabilities for clips in a whole game? Secondly, how many of our top picks are highlight worthy? And thirdly, does our signal probability rating represent the true probability of a clip being signaled? So, the probability distribution of clips for the 4 test games is seen here. So as is seen in these images, the majority of clips are classified as background. So at least from looking at the data visualization, you know we're onto the right track. I was going to include some animated GIFs here, but they don't seem to work in Google Slides. So I've just included an image. And I've noted what the algorithms here, or what we created, actually brought up. So if you could actually watch this clip, this guy makes an incredible 3-point. I believe it's this one down here, and it's incredible. The whole crowd jump up and stuff. So yeah, that was very accurate pointing it out. Also come up with the other 4 there that we feel are notable. Same with this one, makes a great 3-point shot again. Here we made a 2-point layup. It's actually this guy here who runs the length of the court, does something rather spectacular. And in the final one, it's not as impressive, which I think it's quite nice that it's shown as 0.69 rather than like up in the 80s. So I'm just going to move on to next steps after this. So there are many additional steps that could be used to improve the performance of the highlight classifier, and there are a number of challenges to be solved before using the classifier practically on a large scale. So some of these are performance related, such as fast processing and creation of the audio images. Others are more practical, such as we need to be able to determine which team a highlight is for, so we don't suggest, for example, that a player tag highlight of someone getting dunked on, or, for example, in football, you recommend to the goalkeeper him like not saving something. So additionally, there are improvements to the classifiers themselves. These can include an increase in the size of the training sample of performing more pre-processing of the data to make signal or background discrimination easier. The last and perhaps most important step is the optimization of the video classifiers. So right now, these video classifiers provide minimal value when combined with the audio classifiers, but this value could be increased substantially if we were to standardize the location of the cheering within each clip. So this would help us to distinguish between impressive successful shots, free throws, which is a basketball term if you're aware, and plays that occur from the basket. Thank you. We can put this down now. So I hope that all made sense. Oh, thank you. So just so you're aware, if you got really bored of my voice or fell asleep during that, or you thought the whole thing was just incredible and you want to email us to let us know, then you can find all of that information and this blog on Hudl.com blogs page. Just FYI. So, just wrapping up the presentation, I'm just going to go through very quickly some problems and challenges that the data team is having here at Hudl, and like I said, you may be able to empathise with it. So we need more data. It's like a very common thing for data scientists, data analysts, whoever's dealing with data to say, yes, I made the claim that we have the world's largest labeled sports database with all the metadata. We have over 1 billion clips saved in Amazon Web Services servers. However, it's just not enough. So what we're doing right now is actually, most of the things we're doing is automating processes so that we can just keep on creating a better database. High standards. So as I mentioned there, some of the challenges of that, like the highlight recommendation engine for deep learning. It has to really work like 99.99% of the time until we can actually deploy it as a product and use it within as a function in Hudl. Especially the one where I mentioned about statistical probability of plays. If you told a coach, oh, you're more statistically probable to, if you play a free kick like this and then it all goes terribly wrong, who are you going to blame? Hudl, obviously. So you've got to make sure that everything's of high quality. And unified approach. So we want to be making sure that what the data team is doing is actually worthwhile and can be used on various different teams. So used across American football, soccer, golf, volleyball, wrestling, rugby, all the different sports that we're covering. Before I get into questions, just quickly, we're looking for a data warehouse engineer. Any questions? Yes, sir.
3 questions. First, where is your office?
We're based in Islington, so the nearest tube stop is Angel.
Second is, what kind of people work there, teams, what are they dealing with or concentrating on?
Oh, right, so you're asking about the tech stack.
The what?
Are you asking about the technologies that we use?
No. I'm asking about which teams are based in the London office. You said like data scientists spread across America.
Yeah. Good question. So we're building out the London office. So when I started at the beginning of May, we're about 10 people. In London, we're now 15 with 6 accepted offers ready to start. My aim as a technical recruiter is to build us out to 100 before the end of 2016. It's going to be fun. So that's everywhere. So if you're asking the type of people that we're going to get involved, yes, we're going to have more data scientists, data engineers, product managers, iOS and Android developers, infrastructure engineers, quality analysts, QA engineers, and I'm probably missing a few out there, but of course designers as well. So I hope that answers your question.
Last question.
Yeah.
You have also people working in the London office dealing with open source technologies. I can see already some.
Yes. So we are all our infrastructure is written in C#, everything's on .NET. But if you look at, I'm just going to cover this very briefly. If you look at the front end, it's all HTML5, CSS3, and JavaScript. The main framework that we use is Backbone, and we use just a whole ton of libraries. And like the most engineers that we hire are, last year only 30% of hires that we made were previously C# engineers. Some of the more common languages like Java, Node.js, Ruby, Python. The data science team purely using Python as well as other bits and pieces, and the MongoDB is our database of choice. Yes, we use SQL Server, but also we use a Hadoop, and we've got Hive and Spark sitting on top of that. We're also trialing using Redshift at the moment to build out our data warehouse.
Thank you.
Sorry.
So you guys use a lot of Amazon Web Services.
Yeah.
Since you're using Hadoop, do you use Elastic MapReduce, or do you use kind of Cloudera or works on top of AWS?
Yeah, good question. I'm afraid I don't know the full answer to that, but if you're asking if we use Elasticsearch as well, then the answer is yes, but I'm afraid I can't answer all those questions. But one thing to add, I can, if anyone wants to ask any more in-depth technical questions, rather about like deep learning, machine learning, anything data science side or data engineering, I'm more than happy to put you in touch with our data team, and you can just ask them away. They've expressed that they're more than happy to do so.
A less technical question then.
Yeah.
Is the reason why Dallas Mavericks are not a customer is because Mark Cuban tried to buy your company?
I have no idea about that. I actually asked myself and got a bit of stern. Yeah, we're very much trying to bring them on, so we have no hard feelings to them whatsoever. Okay. That's a very PC answer. Yeah.
So is the goal to help coaches in real time to make plays?
No, we're not essentially real time, because if you think about real time, they're watching the game whilst videoing. But it's more, analysis. So going over the video.
Really after the game analysis.
Yeah. So what you can do during real time is be tagging the game. So and it's really easy to do so either on iPad or mobile, or if you've got your laptop on the field. And when I say by tagging the game, like that player just did that, etc. It's more for so the athlete on the way home or at home or something can look at all over their plays. The coaches can say, look, for next practice game, I really want you to look at this specific clip and really think about how you're going to change that and do better in these particular ways. Does that answer your question?
Yeah. And so another question.
Yeah.
So you talked a lot about highlight-worthy clips.
Yeah.
I guess you could also use the same technology to decide whether a game is exciting, or which are the most exciting games for fans to watch.
Yeah, that's a really good question. But what we use our video for is like none of it would be released externally. Well, so you wouldn't see it on like Sky Sports or anything like that. The only time we're actually using this video publicly is when, for example, because a lot of our teams, professional teams, have been using, especially in the States, been using Hudl for so many years. We actually have like players in the NFL. We have them at high school, college level, all their clips, and we can create like a "This is your life" like montage of everything. But it purely be for like the teams, and whether I saw from the video clip at the beginning, you can exchange that video with other teams.
I mean, with regards to your question about kind of real time, it's probably not got to that level yet. I don't know if you've seen Atletico Madrid, the assistant manager was wearing Google Glass, was getting updates during the match, and so there are some teams kind of doing that kind of stuff. More often than not, it'll be like a mad rush to get something done for half time. So you'll have a kind of 2 minutes, few more clips. Your left winger's getting absolutely hammered here. He's not tracking back, whatever it is. A few kind of quick clips and out, and then the kind of more detailed analysis post game.